This video is going to illustrate the use of crystal ball by going over a very simple example, predicting annual income. We'll demonstrate the way to predict annual income using normal Excel formulas, and then we'll go back over it and show how you might predict annual income based using crystal ball. Annual income can be predicted by multiplying three pieces of information. One is how much the hourly rate of pay is, the number of hours worked per week, and then the number of weeks worked per year. But if you simply have a range, in other words, the hourly pay would be between 15 and 20, but you're not sure exactly what, when you use Excel, all you can really do is say, well, we'll just take the average. So we'll put in $17.50, and we'll just make that a dollar figure. So that's the average of the hourly pay. The average number of hours worked per week would simply be the midpoint between 25 and 30 hours, so we'll put 27.5 hours, and then here we'll do the same thing, 46.5 hours. Now, if I want to figure out the total income, I would simply use an Excel formula which multiplies C3 times C5 times C7. Oops. Okay, and we come up with the sum that you see there. Well, there's a couple of problems with this, and that if you had some more information about your what your hourly pay range might be. In other words, if you thought that while the pay range is between 15 and 20, it'd be more likely to be in the upper ranges, more like 18 or 19. Then this Excel formula doesn't really take that into account. All it takes into account is these average amounts. So let's go back and look at what Crystal Ball can do for us. And if you've installed Crystal Ball successfully, you will get a tab in Excel that has these items on the ribbon. And we're going to focus on defining assumptions, defining forecasts, and then running a simulation. More about that in just a bit. So let's go click on this figure here, and then we're going to click on Define Assumption. The first thing we get is a choice of distributions. So what are distributions? Let's actually read, and I'd like you to do this as well. You can actually read the distribution description for each one. I'm going to click on Uniform. Notice down here it says, in the uniform distribution, all values between the minimum and the maximum are equally likely to occur. Well, that's a very basic distribution. But there are other distributions that might imply more information about that $17.50 amount. But let's just go over the rest of the uniform distribution. In a uniform distribution, the parameters are minimum and maximum, and all values between the minimum and maximum are likely to occur. So let's click OK and see what we get. And here we see that, and we'll have to change this a bit, the minimum is 15, the maximum is 20, and it's saying that each dollar amount is just as likely as the other. That's why we have this is actually a graph, and this line here is simply saying that the probability of any one dollar value being your hourly pay rate is going to be equally likely. Let's try and look at another gallery. Let's look at a triangular distribution. This one says this is where you know the minimum and maximum, namely $15 and $20, but you also are saying there's a most likely value. And if you read through here, the parameters are, again, the minimum value, the maximum value, and the most likely value. So I'm going to click OK, and now I would put in 15 as the minimum. The midpoint is still the same. The most likely is $17.50, and the maximum is 20. But this says that the probability of the lower amounts or the higher amounts are actually less than the probability of the most likely amount. Unlike the uniform distribution, which thought that all amounts of pay rate were the same, equally as likely, this distribution will more heavily weigh the middle number as opposed to the one on the end. So if we click OK, notice how we get the cell turns green, which means in crystal ball speak, this has been there's an assumption defined here, and if the cell is selected and I click Define Assumption, I'll just get the distribution that I saw before, which allows me to change it. So let's see what else is available. The most common example of the distribution is the normal distribution. So let's click it and see what it asks for. Click OK. Now it's asking for two things. It's asking for the mean, or the average, which is still 1750, but now it's asking me for a standard deviation. And here's just a little bit of statistics and all you really need to know for crystal ball. And actually, what we'll do here is we'll go back to the gallery and let's read the normal distribution. The normal distribution describes many natural phenomena such as IQs, people's heights, so forth and so on. What it means is that there's a distribution of values. And I'm going to click OK again. Actually, I'm going to click on this and click OK. What this shows is that, again, the highest probability is, as you see up here, and it's right about at 1750. But this standard deviation says how likely it is for the number to be less than 1750 or more than 1750. In other words, if you think that the standard deviation is really only $1, then what that's going to mean is going to make this curve narrower, the width of this curve, and it's going to mean that the crystal ball will calculate the average, the annual income using a smaller distribution of numbers, meaning that it's not going to use $15 or $16 or $20 nearly as often as it will use $17.50 as the calculation. I should add here that the way the crystal ball works is that when you click, and we'll do that later, when we click the start button, it's actually going to perform the calculation, which is simply C3 times C7 times 3C3, C5, C7 multiplied together. It's going to perform that 1,000 times or even 10,000 times, depending on how you set the simulation run. And when you perform that calculation, when Excel performs it for you, of course, in an instant, it's actually using different numbers each time, but it's using the numbers based on their likelihood of occurring. So it's going to use the number 1750 as the pay much more frequently than any number on either side of it. But it will still use those numbers, and we'll see that when we finally get our answer, we're going to get a distribution of answers based on the probability of any one number occurring. So let's proceed and we'll see what happens. So I'm going to put a standard deviation of 1. Okay. I'm going to define an assumption here, and here I'm going to say that the expected hours of work, we'll use a triangular distribution here, and now we'll say that the minimum value is 25, the maximum value is 30, and the most likely value is in the middle. But again, the most likely value has a higher probability of occurring than any of the values on either end. So when Crystal Ball runs its simulation, it's going, and if it runs it 1,000 times, it'll more often use a number like 2750 is the number of hours than it will a number like 25 or 30. So you're giving 2750 a higher weight. We'll click OK, and now we see a green background on this cell. Likewise, we'll do the same thing here. And here we'll just choose, now here's an example where I'll say, let's choose log normal. Let's see what it says. The log normal distribution is used in situations where the values are skewed one way or the other. And that's I'm sort of paraphrasing here. And what that means is this. Let's click OK. Actually, I'm going to go, I'm going to stick, that's a little bit more complicated one, so I'm going to go with a triangular distribution just so that we can get to the answer that we're looking for. 45 is the minimum, 48 is the maximum, and 4650 was the most likely. All right, so now we have three values that go into our calculation. So let's look at the total income. Now, I've already calculated using Excel, as we saw before, that the annual income is going to be this amount, but based on these averages. But now I'm going to say, let's define a forecast. And the name is total income. That comes from this cell. And in this units is where I actually have to put in the formula again. So if I click there, you notice it has the equal sign ready for us. So I'm going to key in sum, and I'm just going to type in the same formula I had a second ago. C5, oops, C5 times C7. Okay. Okay, now that's ready to go. So now this turns blue, and we have a forecast to find. So we have three assumptions where we added a little bit of information to make the prediction more accurate, and we have a forecast. Let's click Start. And by the way, this section here, the Run section, says 1,000 trials. So it's going to run this calculation, which is C3 times C5 times C7. It's going to do this 1,000 times over, but it's going to use different numbers each time based on the probabilities that I gave it here. So it's going to use 1750, a lot more than the other numbers, but it is going to use the other numbers, 16, 1650, 1550, 15, and so forth, whereas in our first Excel calculation, which we did in the beginning, it would only use one number every time. In fact, it only did one calculation. So let's see what happens. This is going to be pretty quick, so it's going to flash in a second here. Okay, so let me minimize this. Total income. So this total income is the cell value here, and what we now have, and this control panel says we've done a total of we've done the simulation, we've done a total of 1,000 trials, and now it's telling us that the most likely value is this 22,378, but that there's a possibility, or a probability, as this axis shows, of each of these amounts occurring. So there's a very small likelihood that the annual income is going to be $20,000, and a very small likelihood that the income is going to be $26,000, but much more likelihood that the answer is going to fall somewhere in here, that the average, the annual salary. So let's actually close this. We'll close this, and we're going to run the simulation again. This time we're going to do without 10,000 trials. I'm going to reset the simulation, and now we're going to run it again. This time we're going to do 10,000 trials. I'm going to click Start. And now I see a more smooth distribution, and I can see it's the same idea. These numbers are going to be fairly unlikely, as are these, but the likelihood of getting an income up in this area is the highest. So let's reset the simulation. I'm going to clear it. Let's now close this, and I'm going to now say let's do 100,000 simulations. Click Start. Pretty quick. Okay. So now we see that the curve is much more smooth. With 1,000 simulations, 10,000 or 100,000 simulations, we now get a smoother curve, which means that these results are quite a bit more accurate. Now, let's say that you wanted to figure out what the probability was that the annual salary would have been between 21,000 on the low end and 23,000 on the high end. Hit enter. Notice that we've identified only this part of the graph as having values that fall within this salary range. And we're told that there's a 46% chance that the salary is going to be between these two numbers. So what Crystal Ball tells us is that there's a range of possible annual salaries. This is anything in this area is most likely. It's still possible that you'll have some probability that you'll make less and some smaller probability that you'll make more, but there is not a zero chance that you're going to make only 20,000, and there's not a zero chance that you're going to make as much as 25 or 26,000. The most likely number or amount of money you're going to make is going to fall in this category too. So using this simple example, how does this help us in project management? Well, we're going to be doing examples, as you'll see in the next video, where we're given a number of factors that have information that tells us how likely the values are, and it will enable a project manager to predict the probability of a certain amount of money being spent on a project, or a certain amount of money being made in revenue on a project. And in this way, the project manager can report to his superiors or her superiors that the numbers that have been calculated have some probabilities with them. They will be able to say, for instance, there's a 70% probability that a project will bring in X number of dollars in revenue based on the assumptions that were made. So that the executive decisions can be based on this information that they get from the project manager. For instance, if the project manager would say, well, there's only a 50% chance that we're going to make X amount of dollars, the executive management may say, well, that's not enough of a guarantee that we're going to make money overall on this project, so maybe we won't start it. I want to see a project where the calculation says we're going to have a 70% chance of making X amount of return. So this is where Crystal Ball comes in handy, because it can give you, it allows you to put in more information about each value. It allows you to give probabilities for these values, and then when Crystal Ball runs the simulation as many as 100,000 times, and you could even run it more. I mean, we could have run it 1,000,000 times, but when we see the graph, we see that it's really not going to change its shape very much. This allows Crystal Ball to assist your calculations, make them more accurate, and allow you to assign probabilities or percentage chances that a certain event is going to occur. So this is the example that helps us get into Crystal Ball. The next video will show us how we actually can work the problem from Chapter 3 and come up with a value that predicts the income generated from a new project that a company wants to launch, making mouse pads. So I hope this was helpful, and I look forward to you having questions if you do on this or on the next video. So that's it for the first video on the crystal ball.